Hi, this is Scott Vo from AP Physics Period 7, and today I'll be talking to you about the first law of thermodynamics. So what is the first law of thermodynamics, you may ask? The first law of thermodynamics states, energy can be converted from one form to another through heat, work, and internal energy. The second point it makes is energy cannot be created nor destroyed, which is really similar to the law of conservation of matter. It's just the equation of the first law. The equation for the first law of thermodynamics is delta U equals Q plus W, or Q minus W. The reason for there being two different equations is that there are two different possible scenarios. See, as W stands for work done, in a closed internal system, work can either be done by the system, where it will lose energy, or it can do work, where it will gain energy. And you need to know that Q also equals heat transfer. So that covers the variables and the equations for the first law of thermodynamics. So the first law of thermodynamics was discovered by three scientists, Robert Mayer, James Joule, and Hermann Helmholtz. Mainly James Joule, because he's known for thermodynamics, and he was the main contributor to discovering the law. And he's this guy over here with his nice beard. And it's important to know the first law of thermodynamics because energy is used in pretty much all aspects of science and engineering. Because you need to know how energy works in engineering in a system to calculate energy loss, energy gains, and it's also important in the other aspects of science like biology and chemistry because chemical reactions all require energy, they use energy, and pretty much all living systems use energy. So the history of the thermodynamic laws. So the zeroth law was enunciated by Joseph Black in his 1786 lectures on chemistry. Basically what that law means is thermal equilibrium is transitive. First two laws were accepted by 1965. And the second law was basically created by this German physicist named Rudolf Clausius. First law, we already know, states energy is conserved, its form can be converted. And the second law states energies can flow and equilibrates, basically change forms. And the third law associated with this German physicist named Walther Nernst and his 1906 heat theorem, which means driving force for equilibration is uniquely defined. And I probably lost you by now. So the fourth law was created by Lars Onsager in 1952. It's not even like officially the fourth law, but people call it the fourth law. And I'm probably not going to go into it because it's complicated. Okay, so let's move on to example problem for the first law of thermodynamics. A gas in a system has constant pressure. Okay, the surroundings around the system lose 62 joules of heat and does 474 joules of work onto the system. What is the internal energy of the system? Okay, so we're going to use the equation here. And as you can see, the surroundings around the system lose 62 joules of heat. That means the gas in the system is going to gain 62 joules of heat because heat cannot be destroyed. So the heat has to go somewhere. And in this case, it's going to go into the system. And as here agreed, does 474 joules of work onto the system. Because it's onto the system, we're going to have to add it in this case and not use the subtraction formula. So plug all our data into the equation, add them up, and delta U equals 536 joules. And here's a cool video, which I'm not going to play because it'll make my video too long, but you can go ahead and check it out after this video. Here are my works cited. Thanks for watching. Hope you enjoyed the presentation.